In this lesson, we'll be looking at linear functions. But before we get into linear functions, let's look at the general form of a linear function. The general form of a linear function is f is such that x is mapped onto ax plus c. The colon means such that, and the arrow means onto. So when you're reading it, you say f is such that x is mapped onto ax plus c. Or you have f open bracket x close bracket is equals to ax plus c. That is read as f of x is equals to ax plus c. Then you have y is equals to ax plus c, or xy is such that y is equals to ax plus c. Now f is such that f of x and xy is such that y all means y. It's different ways of writing y. So the subject there, if you see f of x or f is such that x, it all means y, which is the function, right? So you go on where a is the coefficient of x, c is the constant term, x is the independent variable, and y is the dependent variable. X is the independent variable because you have to substitute your x values into the function to get your y values. And that makes y dependent on x. And further, you have a and c are real numbers, that is, a and c are elements of R. Let's get into the example. Draw the graph of the linear function. You have two questions there. A, f of x is equals to 2x minus 1, and b, f of x is equals to minus 2x plus 1 for the domain x is greater than or equals to negative 3 and x is less than or equals to 3 using different sheets of graph paper. So at this point you're going to pause the video and copy the questions, and we'll work them in the next slide.
Let's look at our first example. So the linear function is f of x is equals to 2x minus 1, and they said that the domain is x is such that x is greater than or equals to negative 3 and x is less than or equals to 3. This means that our domain would be all the values greater than or equals to negative 3 but less than or equals to 3. So that means it's going from negative 3 to positive 3. And if you notice, I've listed them here: negative 3, negative 2, negative 1, 0, 1, 2, 3. So these are our x values. Now, when you get the x values and you have the function, usually draw up a table and you list all your x values at the top. Here, you would put the function. So if you notice, it's 2x minus 1. So I broke the function into the two terms, and I put one term up here, which is 2x, and the other term here, which is the 1. So it's 2x minus 1. And then here is going to give me the results after I input each one of these values into the function. So let's start. So wherever x is, we have to substitute our various x values. So in this case, it's going to be 2 times negative 3, 2 times negative 2, 2 times negative 1, 2 times 0, 2 times 1, 2 times 2, and 2 times 3. Wherever x is, we put in our x values. So that's why you have negative 3, negative 2, negative 1, 0, 1, 2, 3. Now, let's multiply. 2 times negative 3 is going to give me negative 6. 2 times negative 2 is going to give me negative 4. 2 times negative 1 is going to give me negative 2. 2 times 0 is going to give me 0. 2 times 1 is going to give me 1. 2 times 2 is going to give me 4. And 2 times 3 is going to give me 6. Now, if you look at this term, there is no x, so we don't have to substitute these values into this term. What we do is we just write this term straight through as negative 1 in all our columns. Now we have to find our final answer. So it's going to be negative 6 minus 1, which is going to give me negative 7. Negative 4 minus 1, which is going to give me negative 5. Negative 2 minus 1 is going to give me negative 3. 0 minus 1 is going to give me minus 1. 1 minus 1 is going to give me 0, 4 minus 1 is going to give me 3, and 6 minus 1 is going to give me 5. Now, these are our x values and we call this the domain. So my answers down here would be my y values. So taking x and taking y, we could get our points that we have to plot. So our first point would be -3, -7. Our second point is going to be -2, -5. Our third point is going to be -1, -3. Our fourth point is going to be 0, -1. Our fifth point is going to be 1, 0. The other one is 2, 3. And the last one is 3, 5. Now that we have all of our points, we now have to plot these points to get the straight line for the function 2x minus 1. So we have our points listed there. Let's try to sketch this diagram. So my first point is -3, -7. So you go -3 and you come down to -7. Next we have -2, -5. Then you have -1, -3. Then you have 0, -1. Let me just fix this. So this is going to be 2, -5. And let me just try to get this as accurate as possible. Alright. You have -1, -3, which is going to be about here. Then you have 0, -1. Then you have 1, 0, which is right here. Then you have 2, 3, which is about there. And then you have 3, 5, which is about there. Now when you connect the dots, you should get a straight line. Well, my own won't be a straight line because this is not accurate. But when you draw this on a graph paper, you should get a straight line, and this line is f of x is equals to 2x minus 1. I would now show you a drawing of it on a graph paper and what it should look like. So you could pause the video and copy it from the picture. This is what a graph would look like on a graph paper. So this is the b part. We have our function f of x is equals to minus 2x plus 1 with the domain x is greater than or equals to -3 and x is less than or equals to 3. So my domain values remain the same, -3, -2, -1, 0, 1, 2, 3. So we put that at the top for x. Here we break up our function into terms, so this becomes minus 2x and this is plus 1. So wherever x is, we have to substitute these values. So it's going to be minus 2 times minus 3, minus 2 times minus 2, minus 2 times minus 1, minus 2 times 0, minus 2 times 1, minus 2 times 2, and minus 2 times 3. This would give me -2 times -3 is positive 6, -2 times -2 is positive 4, -2 times -1 is positive 2, -2 times 0 is 0, -2 times 1 is -2, -2 times 2 is -4, and -2 times 3 is -6. There is no x here, so we just put plus 1 straight through. So now let's find our answers. So 6 plus 1 is 7. 4 plus 1 is 5, 2 plus 1 is 3, 0 plus 1 is 1, -2 plus 1 is -1, -4 plus 1 is -3, and -6 plus 1 is -5. So these are my x values and these are my y values, right? So let's write our points. We have -3, 7, then we have -2, 5, then we have -1, 3, then we have 0, 1, then we have 1, negative 1, then we have 2, negative 3, then we have 3, negative 5. Now I won't be plotting this one because I don't have a graph board, but I'll put an image of what the answer should look like. So these are the points you would get when you substitute our domain into this function. So using these points and your graph paper, plot the straight line, and I'm going to add the image for you to see what the answer should look like. This is the solution on the graph paper. You could pause the video and copy it.